Okay, guys, so let's have a look. So all of these are past paper questions. Best way for you to see how the questions are going to be asked is for you to look at past papers. I've said this many a time. I'm sure your teacher says the same thing. There are past paper links on the Google Classroom. Very easy for you to go and access them. Quite literally, you can do them on your phone if you want. All of them come with memos. The November 2023 papers have not yet been posted on those sites, but they will eventually be posted, so you don't have to stress. We did do the inverse question of the 2023 paper on Monday, so you have seen that question. And we'll see if we can get to that one today. We might not, but if not, it's not the end of the world. Like I say, you will eventually get that paper posted and you'll be able to revise it yourself. So, and to be fair, I feel like teenagers have their ways. You probably already have access to the paper and the memo anyways. Because there are definitely places online that you can find it. It's just not the common ones. Alrighty, but let's have a look. So this was from last year's trial papers. So written in September. And what you'll see as you start to go through past papers is that there's sort of a general setup that they like to follow. They like to have a hyperbola question first, as like the basic question. You'll see as we go along. This term has taken it out of me, guys, sorry. You'll see as we go along with these questions, the hyperbola question is very straightforward. If we get to the next paper, you're going to see it starts with the hyperbola question, very straightforward. Nice, easy questions, asymptotes, intercepts with the axes, sketch a graph, lovely. Okay, so it eases you into it with a hyperbola. Generally, they then give you a parabola straight line or parabola something question, which is slightly harder. Still grade 11 work, they can obviously introduce inverses of your parabola there in terms of the root functions, but they step it up with a more slightly complex question, generally 2 graphs combined, and then they have the inverses question. Sometimes they switch up that order, but you can generally expect a hyperbola, a combination of graphs, and then your inverses question somewhere there. And like I said, as you go through the past papers, you're going to see that pattern sort of arise. So this question, like I said, 2023 trial exams, paper 1, because we're doing functions, you were given f of x is equal to 2 over x minus 5 plus 3. Now, guys, what I like to do before I even start with a question is I like to figure out what information I have, what's actually going on here. All right, so firstly, we know this is a hyperbola because of the format of the equation given to me. Because the a value, so because the fraction essentially is positive, I know that this hyperbola sits in quadrants 1 and 3. Now that's going to be important because as you can see, I haven't given you the graph. And I can pretty much guarantee you that if they don't give you the graph, they're going to ask you to sketch the graph. So we're probably going to have to sketch it. Knowing which quadrants we're working in is then very helpful. The next thing that I see is that this graph has undergone 2 transformations. Firstly, this plus 3. Let's actually do this. So this plus 3 is a shift 3 units up, which means that your horizontal asymptote is at y equals 3. I'm not going to write out asymptote. And the next transformation that has happened is this x minus 5 situation, which is a shift 5 units right. This gives us our vertical asymptote at x equals 5. Right, so already I've got a whole bunch of information that's going to help me draw my graph, and it's going to help me answer a bunch of different questions if they ask me range, domain, equations of asymptotes, etc., which is actually the first question. Just as a quick reminder for this last shift, remember if it's x minus p, that's a shift right. If it is x plus p, that's a shift left. So it's always the counterintuitive. When it's negative, we generally think, oh, it should go left, but it's actually going right. So just remember that. So 4.1 says write down the equations of the asymptotes of f. We've already done that because you took 30 seconds to just break down what was happening. you already know that the asymptotes are at x equals 5 and at y equals 3. That's all you need to do. 2 asymptote equations done, no problem. 4.2 is asking you to write down the range of f. Now, what you need to remember is that for hyperbola, your range, which is talking about your y values, will be everywhere except for your asymptote. Now, we know the asymptote is at 3. So this graph exists everywhere except for 3. It goes all the way up, all the way down, but it doesn't cross that asymptote, which means y is an element of real except for y is equal to 3. That is it. When it comes to your domain, it's the same thing. So domain, we now know that we have asymptote at x equals 5. Obviously, they haven't asked you for the domain here, but I'm just going to put it out there because it is basically the same thing. It will stretch all the way to the left, all the way to the right, but will not cut your asymptote. So x elements of R, but x not equal to 5. So just remember for a hyperbola, element of real, for domain or range, and then you just exclude whatever the asymptote is. That is on the summary notes that I put on Google Classroom. So just go back to those if you are feeling a bit confused. 4.3 says determine the coordinates of the x and y intercepts. So can someone tell me? You can raise your hand, unmute yourself, put it in the chat, whatever you're most comfortable with. How do we find the x and y intercepts of any graph? What do we do? How do I find the x and y intercepts of any graph?
Ma'am,
Yes, sorry.
for the x-intercept, you substitute y is equal to 0.
Good. And do you want to give me for the y-intercept, Siba?
X is equal to 0.
Wonderful. Thank you, Siba. Excellent. Guys, that's it. And I've said this before, but for any function, that's how you find the intercepts. Okay, so that's exactly what we need to do. We need to find the x-intercept and we need to find the y-intercept of f. Now remember, f was 2 over x minus 5 plus 3. So I'm going to give you guys 5 minutes. I don't think we should need more than that. I want you to find my x-intercept, and I want you to find the y-intercept for me. I'm going to give you 3 minutes, and then I'll check in if you need more time. I'll give you more time. Feel free to also put answers in on the chat as you find them. It might help someone else. Those of you that are done, How are our maths marks looking for the term? So I think everyone's pretty much finished with assessments. Are we happy? Do we still have some work to do? You can obviously just direct message me. You do not have to post on the chat if you don't want to, but I would like to know how we're feeling as we sort of end off term 1 heading into term 2. No results, guys. All right. I mean, can't force you to share, but it would be nice to know how we're feeling about math so far. I am liking the answers coming through so far, so well done. One more minute and then I'm going to go through it. Okay, guys, let's see. So your x-intercept, you're making y equals 0, so 0 is equal to 2 over x minus 5 plus 3. I prefer to get one term on either side, so I would make this -3 is equal to 2 over x minus 5. And then obviously I don't particularly want that fraction, so I'm going to times both sides by x minus 5 in order to get rid of it on the right. But I will then have it reintroduced on the left. Now remember, you're going to have to distribute that. So please take note of what you are distributing and the signs. Minus 3x plus 15 is equal to 2. So -3x is equal to -13. So x is equal to 13 over 3. I'll write this all neatly in a second. Actually, no, let's just do it here. So your x-intercept is 13 over 3, 0. Don't know why I said, yeah. Your y-intercept, you're going to make x equals 0, so 2 over 0 minus 5 plus 3. You just chuck that into your calculator. You do not need to try and do LCD and all of that. Gives you 13 over 5. So your y-intercept is at 0, 13 over 5, which it seemed like everyone got. So well done. Alrighty. So not too hard to solve linear equations, nice and easy, straightforward. And like I say, guys, the second that they don't give you the graph, you're going to have to sketch it. So we already know where the asymptotes are. We know where the x and y intercepts are. We can sketch this graph quite easily. Now remember, asymptote you draw with a dotted line. So we've got an asymptote at y equals 3. Obviously, you do it with a ruler, not that nonsense that I've just drawn, but we're just going to roll with it. And then we also have 1 at x equals 5, the vertical asymptote. We know that our x-intercept was at 13/3, which is like 4,3 or something, if I'm not mistaken. 4,3 recurring. So again, it's a sketch, doesn't have to be perfect, about there. And then our y-intercept was at 13/5, which is 2.6, so just below your asymptote. And now you've got 1 arm of your hyperbola. Now, we should technically have at least 1 point on each arm. So what you can do is you can substitute in a random value. So I would substitute in 6. So 2/6 minus 5 plus 3. Now, the reason I chose 6 is because I knew it would make my denominator 1. So it makes it a lot easier to work with. So y is 5. That then means that I have a coordinate that I can plot at 6, 5. And so that would be more or less there-ish. Again, it's a sketch, doesn't have to be perfect. And then you kind of know more or less where your second arm needs to go. You should always, like I say, have 1 point on each arm, at least. Sometimes it happens that your x and y intercepts are on the same arm. Sometimes it happens that they're on different arms. It really just depends on the hyperbola you've been given. In this case, unfortunately, it was 2 points on one arm. So I just subbed in a point to get a point, and that was that. Right, now you're sketching, you always get a mark for shape, you'll get a mark for the asymptotes, for the intercepts. It depends on the graph, obviously. But as long as you can get a general idea of what's going on, you should be okay when it comes to sketching. It's 3 or 4 easy marks, so make sure you can sketch your graphs. 4.5 then says, determine the transformation that the graph of f has had to undergo to form the graph of h, where h of x is equal to minus 2/x minus 5 minus 5. So let's just establish what we're working with. We're working with f of x originally, which was 2/x minus 5 plus 3. So 2 things have obviously changed. The first term was a positive fraction. It's now a negative fraction. The second term was a positive 3. It's now a negative 5. Now it depends which transformation you see first. That negative in front of my fraction implies that there's been a reflection over the x-axis. Okay, now remember, if you reflect over the x-axis, the y-coordinate changes sign. So if it was negative, it's now positive. If it was positive, it's now negative. That's happened here, okay? That fraction, because it's become negative, it has changed sign, so we've got that reflection. We can also see the change in sign in the negative 5. Granted, it's negative 5 with a shift, but we can see that change in sign. So this has definitely been reflected about the x-axis. And if we just consider that as an independent or as the first step in my transformation, that would give me a new graph, and I'm just going to call it g of x because it's not yet h of x, of minus 2/x minus 5 minus 3. The y changes sign. This is the y. So all of my terms in my y must change sign. I still now need to get from negative 3 to negative 5. If I'm already at negative 3 and I'm going to negative 5, that is a shift 2 units down. So not only did it reflect about the x-axis, it also shifted 2 units down. So you need to be quite savvy and you need to be quite knowledgeable about your transformations and what happens when you transform a graph in order to figure out what's going on. So a reflection in the x-axis, y changes sign. Reflection in the y-axis, x changes sign. Shift up or down, you've been doing that for years. Any reflection about the line y equals x, that is now the inverse. And we've done a lot of inverse questions already. All right, so just remember all of those things. You did them in grade 8 and grade 9. We now start to apply them in functions, in transformations. I think that might be a bit small, so I'm going to do the first 3 questions if you want to take a screenshot, and then I'll scroll down. Guys, remember, if you've got questions, please ask as I go along. Okay, and then the last 2. So like I said, this is the nice, easy one. We then move on to the slightly more complex question when it gets to the parabolas, and then it's generally a parabola, an exponential parabola, and straight line. It's generally 2 graphs. Okay, so question 6. The diagram below shows the graphs of f of x equals x squared minus 6x plus 11, and g of x equals ax plus b. The graphs of f and g intersect at s and t, where t is the turning point of f. The angle of inclination of g is 63,44 degrees. All right, so angle of inclination is bringing in analytical geometry. So if we just, again, before we even look at the questions, we just establish what it is we're working with here. First things first is you've been given a parabola. Now, obviously, guys, your graphs are labeled, so there's no need to go and color coordinate them, but I'm just really highlighting for us what's what. So there's our parabola, and then we also have our straight line. Again, it's labeled. You don't need to stress about this, but there it is. The next thing that we've been given is the angle of inclination, and there's my angle of inclination. There's 63,44. Now, what I want you to remember is that tan of your angle of inclination is equal to your gradient. This is what we learned in analytical geometry in grade 11. And we bring it up in graphs with this exact sort of scenario where we need you to find a gradient. So what you need to take away from that is, if you go and now put tan of 63,44 in on your calculator, you will have the gradient of g. And that's going to be important because if you have a look at g of x, you don't know a and you don't know b. A is your gradient, b is your y-intercept. You're probably going to have to go and find them. But let's see what the questions actually ask us to do. So the first question is asking us to calculate the coordinate of t. Now remember, t, they told us, was the turning point. No. Okay, we're going to keep trying until we get it right. Turning point. Okay, it is the turning point. We don't need to stress. I don't know what's happened. We're just going to roll with it. So, turning point. Now I've made everything small. Okay. I'm not going to fight with it. Now, there are a couple different ways that you can calculate your turning point. You can work out your turning point by completing the square. You can work out your turning point by using the formula minus b over 2a. You can work out the turning point by using the first derivative. If you have done calculus already and you know the first derivative, I've got no issues with you using the first derivative. There's nothing wrong with that. So there are a few ways that you can go and work out this turning point, and it is completely up to you what you choose to do. Okay, it's your choice. Because we have not done calculus yet together, I am going, oh, why do you hate me? I am not going to use derivatives. I'm going to use the formula. I would not complete the square personally. Completing the square is just a mission. And so I would use the formula minus b over 2a. I really hope I don't have to write like this the whole lesson. I'm hoping my pen's going to work. Okay, so minus b over 2a, your formula has to be in standard form to do that. It was. I don't know. Okay, we're just gonna roll with it. It's gonna be fine. So f of x was equal to x squared minus 6x plus 11, if I'm not mistaken. Just double check that. Yep. And so we can now substitute in. So it'd be minus b, so minus 6 over 2a, so 2 times 1. Now minus 6 is 6, divided by 2 is 3. So the x coordinate of your turning point is 3. We would then substitute that back into your original equation to get y. And so what that means is that t is at 3. If we sub this back in, we get 3 squared minus 6 times 3 plus 11. And you end up with a y coordinate for t, or for your turning point, of 2. So t is equal to 3, 2. Six 6.2 is asking you to find the equation of g in the form y equals mx plus c. So remember, you've got your gradient and you've got your y-intercept. We have been told that the angle of inclination is 63,44 degrees. Now, I've already explained that whole town thing. I'm going to see if I can get my pen working. It is going to mean that I have to stop sharing my screen for a second. But I want you to quickly go and see, while I'm trying to figure this out, if you can work out this equation for our straight line. So 63,44. I'm hopefully going to share again in a second. Seems to be okay. Long may it last. Right, so remember I said I didn't want to last. That tan of theta is equal to m. And so all we need to now do is say tan of 63,44. Or if you can hear the clicking, I'm sorry, it's very annoying, but this is where we're at now because my pen is just being difficult, you know? You just type this into your calculator. It does give you 2.00 something, but if you round that off, which generally they're going to want you to do, your m value here is 2. So you now know y is equal to 2x plus c. Now, if you go up to your straight line passes through t. You've just worked out the coordinates of t. So what we will do is we will now substitute the coordinates of t into this equation to solve for c. So t was at 3, 2. So 2 is equal to 2 times 3 plus c. 2 times 3 is 6. Bring it over, becomes minus 6, so minus 4 is equal to c. And so your equation is y, and remember, write it in the format they want. Y is equal to 2x minus 4. And that is the equation of your straight line. Right, guys, I'm really sorry about this pen situation. I wish I could figure out what its issue is. But we're going to roll with it. Right, so 6.3 says, hence or otherwise determine the coordinates of S. So if you look at where S is, who can tell me what is special about point S? What type of point is S? Nice, Emmanuel. It's a point of intersection. Come on, I know you want to work. It really doesn't. Okay, it is a point of intersection. Now you have got both the straight line and the parabola's equations, which means that we can go and find our point of intersection. How do we usually find a point of intersection? What do we do? Good, Emmanuel. We equate those two graphs. This is just going to be painful for all of us. We're going to make plans. You know, got to make plans. Right, it's a point of intersection. Exactly. So what that means we have to now do is we now need to take the graph of f of x and we need to equate it to the graph of g of x. Now you have got both of those equations, right? We know that f of x is equal to x squared minus 6x plus 11. And we've just worked out that gx is 2x minus 4. Sorry. So we can go and equate those two exactly like I've done over here. So I've made them equal to each other, and we can go and solve for x. Now, guys, importantly, the question says to us, determine the coordinates of s. What that means is I want both x and y. Sometimes the question says to calculate or determine the x coordinate or the x value of s. Then you will just stop it after you found x. But in this case, it says coordinates. It wants both. So I'm going to give you 3 minutes. I want you to tell me what the coordinates of S are. Remember, you're welcome to put it in the chat as well. Nice, guys, all done. I'm going to give you a few more minutes. So a few more, like 1 or 2. All right, lovely children, let's have a look. I think I've figured out a solution to the problem, but we'll see how we go. I have apparently not. So I have not figured out a solution to the problem. So, you know, we live and we learn. I'm trying with my finger. Right, so you have to get standard form. So x squared minus 8x, bring the 4 over, plus 15 is equal to 0. Now, guys, what's really important is from this point, if you choose to use the quadratic formula, which is fine, remember quadratic formula is x is equal to minus b plus or minus square root, blah, blah, blah. I'm not going to write the whole thing because I'm using my finger because my pen doesn't want to work. You need to show the substitution. You do not need to write the formula straight off the formula sheet, but you need to show your substitution into the formula. Otherwise, you just factorize. In this case, you get x minus 3, x minus 5, which means your two x values are 3, 5. Now, if we just go back up to our graph, cool, just ignore the writing. That's going to stay with us apparently. You have got a point of intersection at T and at S. Now, T we've already worked out. T is at T was our turning point, which means that we've already got one coordinate there, and that was this value over here. So we actually only need to work with a 5. You substitute that back into either one of your equations. It doesn't matter which one, and you will get that S is at 5, 6. Okay, that's just through substituting back and getting, I don't know, there's so many things happening here, and getting your corresponding Y value. Right. So apparently this annotation is going to roll with us. So I'm going to say take a screenshot of this beautiful mess that is happening here. And then I'm going to have to erase it if I want to scroll. So, you know, what's Wednesdays without a little hiccup in life? Right, so screenshot this. I am also going to let you screenshot the earlier stuff just in case. But I'm going to have to erase all of this. Don't worry, my pen will be working on Monday. We won't have this drama again. Okay. Get rid of that. Are you being serious? Okay, I feel comfortable, feel confident. Great. Right. If you want to take a screenshot of those first 3 questions, there you go. Not even first 3, first 2. Okay, so if we go to 6.4, 6.4 is now where we have some inequalities. And I'm actually just going to put this over here so we can work with this. Now, we've already got some coordinates here, which I'm going to say I'm going to put on the graph. But, you know, guys, who knows what's going to happen here. So we already know that T is at 3, 2. Just ignore the weird bracket and beautiful writing. And we've just worked out that S is at 5, 6. Again, not my best brackets in the world, but we're going to roll with it because this is apparently what's happening tonight. Right. So because you've got this information, because you've worked it all out and now you've got these questions, they're obviously going to be important. So the first question is saying to us, determine the values of x for which f of x is less than or equal to 6. Now remember, f of x is just a fancy way of saying y. So I want to know where all the y values are below 6. Now we've just worked out a y coordinate that is 6. It's going through that point S. So everything below is less than 6. So basically it's asking us to work with this bump of our parabola. It wants to know what x values, what x values exist for that bump. So if I draw my line again, which apparently I can't do. Okay, we're just going to roll with that line. It's going to be good enough. So if we've got this line, this is where y is equal to 6, as we can clearly see. There it is. We need to know what are the x values at this point and at this point. Now we've already got the x value on the right-hand side. That's 5. But I need to go and work out this x value over here. Now there's potentially a few ways you could do it, but what you need to remember is that a parabola has symmetry through its turning point. So when you put a vertical line through its turning point, it is symmetrical, obviously a straight line, not that squonky thing. It is symmetrical about it either side. So there's a mirror image created when you go and put that vertical line through your turning point, creates this mirror image. So what that means is that whatever this point S is, has a mirror image on the other side at this coordinate that I want. And this is now the concept that I need to use to go and work out what is this x value. We know that here the y value is equal to 6. It's a horizontal line, so it has to be equal to 6. We now need to figure out what the x coordinate is. Now there's a couple ways that you could do it. You can go and substitute 6 into your parabola and you can solve for x. That's fine. You would be saying x squared minus 6x plus 11 equals 6. Bring it over, solve for x, that's fine. But there's a much easier way to do it using symmetry. Okay, so the whole concept or the whole idea of a mirror image says to us that the distance from the line of reflection to the point you're working with is exactly the same on either side. Exactly the same. So this vertical line has an x coordinate of 3. Remember, that was the x coordinate of my turning point, which means that if I've got x is 3 on the purple line, to get to the orange line at 5, that is 2 units, which means that this point that I'm concerned about is also 2 units away from my line of reflection. Now, if it's 2 units to the left of a line that's at x equals 3, that means that this x coordinate here is at 1. And so what that means is that my inequality is that it's for all x values greater than or equal to, I don't know why I said negative 1, but less than or equal to 5, because of the x values at those 2 points on my parabola. I'm fully aware that my writing is very unneat because I'm trying to use a mouse to do all of this. But hopefully what you can see is that everywhere below, so from those 2 points, that's where all the y values are less than x. And we just need to go and figure out what those x values are. The easiest way is to use symmetry. You can go and substitute in. I just think, why solve a quadratic equation if you don't have to? But obviously you can. You would then substitute y equals 6 and then solve for x. Like I say, why solve a quadratic if you don't have to? But obviously, if that's what you're more comfortable with, that's what you should do. There's nothing wrong with that. All right, the second question says, determine the values of k, for which f of x plus k will have real roots rather. All right, so to do this, there's a couple of things we need to be reminded of. Before we do this, so I want to take all the scribble off my graph. So if you guys want to take a screenshot of those scribbles to go with 6.4.1, you can, and then I'll explain this next one. This is a question that typically we don't like. I feel like whenever we see this f of x plus k or f of x equals k, we panic a little bit. It is not a hard concept. It's understanding what it's saying to you about the roots. That's all it is. Okay. Pen is working. We're not going to jinx it. I jinxed it. Okay, hope you've got your screenshots. I'm going to take all those scribbles off this graph because it would be nice to be able to use it. So, goodbye. All right, so guys, this last question, this K question. Firstly, what I wanted to remind you of is where roots are, what they are. So when we're talking about roots, we're talking about where a parabola cuts your x-axis. So this first one that I have here is, you can clearly see it's cutting in 2 distinct places. So this would be a situation of two, no, it's not that way. I tried my best, of two unequal roots. Unequal because the x-intercepts are different from each other. They aren't cutting the x-axis at the same point. So this first scenario, two unequal roots. This next scenario, hopefully what you can see here is the fact that it's cutting my x-axis, but the turning point is actually what is on my x-axis. So it actually only cuts my x-axis once. Technically, if you found the x-intercept, you would still get two solutions, but the solutions would be the same, right? So this is a situation where I've got two equal roots. So two roots, but they just happen to be the same. In this last one, hopefully what you can see is that it's not cutting the x-axis at all. Here's my x-axis. There is no x-intercept whatsoever. And this is now a scenario where we are working with non-real roots. So when your parabola does not cut the x-axis, you have got non-real roots. There are no x-intercepts. And if you look at our parabola that we were given, that we are now wanting to work with, that's exactly what we have. We have got a parabola that sits above my x-axis and is not cutting the x-axis at all. So it has non-real roots. It's following situation 3 there. So what this question is asking us to do is it's asking us to determine where this graph will eventually have real roots. So where it will have a situation like this or a situation like this. So let's go to the graph. If I take my graph and I move it up, do you see that I just continue to have non-real roots? I'm actually just getting further and further away from an x-intercept. So this graph definitely can't move up if I want real roots. However, if I move this graph down, I can see that if I move it down, now remember t was at 3, 2. This coordinate here was at 3, 2, which means t to the x-axis is 2 units, because that's the y coordinate. That means if I move this graph 2 units down, it's going to touch the y-axis. And so we have a situation like situation over 2 over here. I'm happy with that. That's real roots. If I continue to move my graph more than 2 units down, what I now start to see is that I'm getting 2 distinct real roots of my graph. And so that's essentially what I want. I now need to move this graph down by by 2 units or more than 2 units. Now look at this. F of x plus k. F of x was x squared minus 6x plus 11. And now I'm plussing k. I, however, need to move it down. A shift down would be minus 2 units or minus 3 units or minus 4 units or whatever. So I need to move it at least 2 units down, and we would need to have negative 2 because that represents my shift down in the way that this has been set up, f of x plus k. It needs to go at least 2 units, but it can go more than 2 units down. So the k would need to be less than or equal to negative 2. Less than or equal to negative 2, because negative 2 will take me onto the x-axis, real roots. Less than negative 2 would be negative 3, negative 4, negative 5. We're going less and less. We're going more and more negative. Negative 3, 3 units down, 2 real roots. Negative 4, 2 real roots. Negative 5, 2 real roots. So when you get questions like this, you need to go back to these 3 basics over here of your roots. And you need to think about, how should I be shifting my graph up or down in order to create whatever the situation is. They often go with real roots or they go with non-real roots. Sometimes I've seen them say 2 distinct real roots, and so then there have to be 2 different roots. But generally speaking, like I said, don't take my word because this is generally they approach it as either real roots or non-real roots. So you need to consider your shift up or down in order to create the scenario they've wanted for you. And you need to remember equal roots, unequal roots rather, equal roots, and non-real roots. Those will give you the different scenarios that you're working with. So again,